Okay, welcome back. It is 1:47 p.m. in the morning on Thursday. And I have finally been able to get back to doing more recording. So our next topic is how to define and call functions in Python. Basically, a function definition starts with the def, D-E-F keyword. Following that is the name that you want your function to have, and the rules for function names is the same as the rules for any other identifier, like for a variable. Following the function name, you have to have a pair of parentheses that may or may not contain parameters. It is fine for a function to take no parameters. For example, I could say define say hi with no parameters, and I do have to have a colon at the end of the, or following the closing parenthesis, and here I can just say print hello. Well, hi, right? So I'm just going to say print hi as the statement within the definition of this function. Notice that the statements do have to be indented, just as they would have to be indented within an if-else or within a for or a while. And the function definition is complete when either, in this interactive case, I pressed a blank line, I typed 2 lines to conclude the function definition, or if Python encounters another line of code that is indented at the same level as the def word. All right, so now I've got this function defined, and I can just say, I can invoke the function by typing say hi with parentheses. There we are. Now, most functions do take parameters, and parameters are in 2 categories. There are what are called positional parameters. Those have to come first, and they are simply variable names, identifier names, that are used within the function. The second category of parameters are so-called keyword parameters, and they have to come after all of the positional parameters. Their form is you have some identifier, which is the internal name of that parameter, and then an equal sign and a default value that you want that parameter to take on if the user does not specify a value for that particular parameter. You can have as many positional parameters as you like. You can have as many keyword parameters as you like. You just have to have all of your positional parameters prior to all of your keyword parameters. Here on the bottom of slide 18, I have a function that I'm defining named retpow that returns x to the y power. That is, it returns the first argument value to the power of the second argument value. And that second parameter here, called y, has a default value of 2. All right, the body of this function is going to contain a return statement, which is how you can have the function return a value back to whoever called it. My say hi function up here did not have a return statement, so it did not return a value. I'm going to return in retpow x to the y power. And I press enter twice because I'm defining this thing interactively. All right, so now if I call retpow by saying retpow 5, I've only given one argument, one positional argument, and so the variable, the positional parameter x, takes on that value 5. Y is also created, and y has its default value of 2. So what's going to be computed and returned here is 5 squared, or 25. If I call retpow and I say something like 5, 3, well, in this case, I'm specifying 2 positional arguments. X receives the first argument value, so the positional parameter X receives the 5. And the keyword parameter Y will act as a positional parameter if you don't specify its name. So in effect here, Y is going to get the value 3 rather than using its default value of 2. And 5 cubed is going to be 125. Okay? Now I can, if I wish, specify Y by name. Now, can I do 4 to the 5th power in my head? 1024? Yeah, of course, of course. 4 to the 5th power is the same as 2 to the 10th power, so it is going to be 1024. And so here, X gets this positional value 4, Y gets the value 5, the explicit value 5, and I get 1024 as my result. You can specify names for both positional and keyword parameters, which may seem a little odd. I can say X is 2, Y is 3, and that'll work. So this is going to compute 2 cubed is 8. And if I do specify both names, I can change the order of these things. So here we're also going to compute 2 cubed is 8. All right, so this is frankly confusing. What we're indicating here is that you can use you can use a keyword parameter like Y as though it were a positional parameter. You can also use a positional parameter like X as though it were a keyword parameter. The one thing that you can't do, though, is to put your positional values after your keyword values, your keyword arguments. So if I tried to say this, Y gets 3, 2. Python is not bright enough to understand. Well, the user here is setting the keyword parameter Y to 3. So if I've got one more value, I guess maybe that goes with X. No, because the rule is that all positional arguments have to come ahead of all keyword arguments, and I don't have the correct order here, so I get yelled at that I have a positional argument following a keyword argument. All right, so that's kind of the one situation that doesn't actually work. In reality, people don't usually name positional parameters explicitly, and so the most common kinds of calls are to just specify a positional argument or some number of positional arguments and let the keywords be their defaults, or specify all the arguments as positional, or specify the positional arguments first followed by the keyword arguments. Now, as a reminder, we've actually seen this in use already. We've said things like print 5, 2.7, hello, false. That's using positional arguments. But I also know that I can define my separator, which is one of the keyword arguments that print provides, to be a comma, or I can specify my or I can specify my end parameter to be, well, let's say an exclamation mark and a new line. The default is just new line. All right, so here I've got an exclamation mark and a new line on the end. What I can't do is I can't move these keyword arguments ahead of any of the positional arguments. Okay, I'm going to yell that when I try to do this. All right, positional argument follows keyword argument. Okay, so here on slide 19 are examples very similar to the ones that I walked through interactively. Of course, you can try these things out. Now, a variadic function is a function that's allowed to take a varying number of arguments. The definition for a non-variadic function that we looked at here is able to take some arbitrary number of positional parameters as long as you give names for the parameters, and also some arbitrary number of keyword parameters as long as you give names and initial values for those variables. So to enhance this, if you will, to allow for variadic functions, if we want the function to be able to accept as many positional arguments as we would like, then what we do is we put in the special parameter star args as the final one of the positional parameters. Now, star args is the conventional parameter designation here. Args is the conventional name to use. In fact, that name is unimportant. I could have called it star banana or star ABCD, but if you do that, it will just confuse people who are trying to read your code. So this is a variadic function that has 3 required positional parameters and then an optional variadic positional parameter that is that can accept arbitrary numbers of additional positional arguments. And the way star args works is within the body of your code, within the body of your function, you can then use args as a tuple containing all the trailing arguments. So let me define this very fun function. Very fun. With 3 required positional parameters, A, B, C, star args, and 1 variadic positional argument at the end, then my colon, and all I'm going to do to illustrate how these arguments are being passed in is to print is to print A, B, C, and args. Now, when I say star args as the positional parameter name, what that means is that args itself is going to be a tuple. So if I now call very fun with, let's say, just 3 argument values. Okay, I keep flipping back and forth between these terms, argument and parameter. I should explain that the parameter is the name given for the variable in the definition of the function. The argument is the value that gets passed into that function. So the argument becomes the parameter's initial value when the function is called. All right, so I'm going to just say 4, 6, 8. I'm providing 3 positional arguments here. And so what I get is the parameter A has the value 4. The parameter B has the value 6. the parameter c has the value 8. Args exists, but it's an empty tuple. If I don't give enough arguments, well, this function requires 3 positional arguments, so I'm going to get yelled at that I'm missing one required argument. If I give more than 3, then the first 3 arguments become the values of the 3 positional parameters a, b, and c, and all the remaining arguments get put into a tuple, which internally in the function is called args. All right, so I've got 3, 4, 5 as individual values, and then I've got this tuple containing these 4 values, 6, 7, 8, and 9. So that's what's going on here on slide 21. In this next example, I'm defining a function called mySum that takes some arbitrary number of arguments and returns the sum of those arguments. Now, I just want to mention, okay, let me create, all right, we know about comprehension, so let me create a list of some values. No, actually that won't work. I'm going to ask you to do this in the homework. But my function here is not bright enough to understand how to compute the sum of items in a list. All right. There is a function called sum that takes an iterable and that returns the sum of the values in that iterable. So 0 plus 1, 2, 3, 4 turns out to be 10. What I'm doing here is defining my own sum function that instead of taking an iterable, takes some arbitrary number of individual values. I'm not trying to suggest that you should use this thing I'm defining here instead of the sum function. I'm just using mySum as an example of a slightly longer function definition. All right, so define mySum star args, and the first thing I'm going to do is to just print as output the arguments that have been passed in. That's going to print as a tuple. Now, to get my sum, I'm going to assume that the default sum is 0. That may or may not be a good assumption. But this will handle the case where the user passes in no argument values at all. At least they will get back some valid number as opposed to getting back garbage. So we'll set our sum to 0 initially, and then we'll say for v, some value in all of the arguments. Okay, remember that args is a tuple, so args is iterable. I'm going to say sum plus gets the current value from the, as we're looping through the values in this iterable. When I'm all done with this, I'm going to return the sum that I have computed. I should probably not have used the name sum here, since sum is also a function, but Python will let me get away with it. And now I can say my sum, 1, 2, 3, 4, 5, let's say. Now that is going to be 15, or my sum 4, 5, 6, 7, 8, 9, 10. You know, I don't know what that's going to be off the top of my head. Turns out to be 85. Okay, so the print statement here is printing the tuple, just to confirm that it is a tuple. And then the return value is the sum of all of the values within the tuple that have been looped through and added up. Alrighty. So that is how you extend and allow the function to receive an arbitrary number of positional argument values. You can also extend the function and let it receive some arbitrary number of keyword arguments by using the star notation, and in this case the conventional variable name is kwargs, for keyword args, obviously. Well, I say obviously. I don't know if it's obvious, but that's what it stands for. Again, you can use, fish or boot or WXYZ or whatever you want rather than kwargs, but kwargs is what people conventionally do. Alrighty, so this thing becomes, I'm going to jump ahead a moment, kwargs becomes a dictionary, whereas args is a tuple. So here I'm defining this function vf2, and it takes one required positional argument followed by optional additional positional arguments. It also has one keyword argument followed by optional additional keyword arguments. Again, I'm following the rule here that the positional arguments, the positional parameters in my definition, all have to come before my keyword parameters. So let's complete the definition of this thing. And all I'm doing is displaying the arguments that are coming in. Let me copy and paste this so I don't have to manually type it all in here. So I'm going to copy the def line, and I'll copy the print function. And now let's call this thing to see how it's working. I'm going to say vf2 with these values 1, 2, 3, 4. Those are my positional arguments. Then here's my first keyword argument. B gets 5. And now I can create additional keyword arguments with any identifier names that I wish for my variable names for my keyword arguments. So I'm going to say age is initially 6, height in inches is initially 70, name is Joe. There we are. So this first value, 1, is going to become the value of the parameter A. All of the trailing positional arguments are going to get put into the tuple args. The variable B, the keyword variable B, is going to be given the value 5 rather than its default value of 4. And I have 3 more additional keyword arguments, age, height, and name, with values 6, 70, and Joe. And those things get put into a dictionary named kwargs. So the name is going to be the key, and the corresponding value is going to be the value within this dictionary kwargs. All right, so let's hit the enter key and see what we get. There we are. So in the print statement, I'm first printing the value of A, which is 1. That's the value given to the first parameter. Then I'm printing args, the tuple, which in this particular call is receiving the trailing 3 positional argument values. All right, so 2, 3, and 4 are in the tuple args. Then B has the provided value 5 rather than the default value of 42. And kwargs is a dictionary, as you can see, composed of age, height, and name as keys. And notice that those are automatically converted to strings, with 670 and Joe as the values corresponding to those keys. Okay, so we've taken a look at defining simple functions, the distinction between positional parameters versus keyword parameters. Positional parameters have to come before keyword parameters. And we've also introduced args and kwargs as a way of receiving an arbitrary number of positional parameters and or an arbitrary number of additional keyword parameters. Very often when you create code, you're going to want to save that code, that collection of functions, for example, so that you can reuse that code later in some other project. Or you may wish to make your code available for other people to use. So what you do is you define a module containing all of your code. And a module is simply a file whose name ends in .py. Okay, and then in there you can put your function definitions, your class definitions, which we don't know how to do yet, variable definitions, etc., to make available to whoever wants to use that module. It's also possible to create a hierarchy of modules called a package, but we're going to we're not going to delve into all of the machinery that you need to set that up. All right, now when you run a module, that module is referred to as the main module. The main module is whatever module you are currently running. Let me okay, I want to create a little example here. So I'm going to say File, New File, and let me pull my editor window over where we can see it. All right, here's my editor window. And this is my test module, testmod.py. It's very clever. You'll notice that the file is untitled so far. I want to say File, Save As, and I do have some programs already in my DFP A4 2020 directory. This one's going to be, what did I call it? Testmod, okay, with no underscore. So testmod.py is going to be the name of this test module. Okay, now, so when I run this module, it is the so-called main module, and it may choose to import other modules. So, for example, I can say print, I am the testmod.py module, and when I save this by saying File, Save, and run it, then while this module is, because I'm running this module is the main module. And I get out, I am the testmod.py module. Okay. Now, this module may import other modules. So I could say something like import math as m, and then I can say the value of pi is approximately m.pi. So now I have imported the math module, and I'm using one of the facilities from the math module, which is the predefined variable pi. And of course, pi is, infinitely many decimal places, and I can only represent a finite number of those, so it's not going to be exact, but okay, so here is approximately the value of pi. Now, even the interactive shell, here, if I'm just typing commands right at the shell prompt, the interactive shell always considers itself to be the main module. Well, what does this matter? I mean, what is this main module business about? It turns out that every module has a predefined variable available to it called __name__. In real life, nobody is able to pronounce or willing to pronounce __name__ over and over again. So variables such as this are called double underscore variables or dunder variables, or just dunders. All right, so if at my interactive shell I type dunder name, okay, __name__, so double underscore name or dunder name, I'm told, oh, well, my interactive shell is currently the main module. It is the top level module that's doing all the work, and it may or may not be using other modules. Okay? In fact, dunder name is only one of many variables that are predefined within the shell. And of course, I've interactively defined a bunch more. You can see what variables currently exist in your interactive shell with the vars function. And what this gives you is a dictionary, a dict, of all of the so-called global or top-level variables that the shell currently knows about. The very first one in any module is dunder name. And in my interactive shell, I see that dunder name is equal to dunder main, or technically dunder name is the key, and dunder main is the value associated with that key. I also have dunder doc and dunder package, and various other things. I've got argv that I defined. I've got M, that's the abbreviated name that I used for the math module when I did my import function. Okay, now I skipped a page, so let me back up. So a module, I did actually say this verbally, but let me just repeat it. So a module can contain a combination of definitions of variables that have important values, definitions of functions, definitions of classes. When you do the import of a module, the name of the module that you import is the base of the file name without the .py. So when I say import math, well, let me say import my module. When I say import my module, the Python shell goes out looking for a file whose name is mymodule.py and pulls in an entire copy of that module file, mymodule.py. If you make the mistake of saying import mymodule.py, this actually will fail because the shell will go out looking for a file whose name is mymodule.py.py. And you probably don't have any file named mymodule.py.py. So remember that when you define a module of code and you want to import that module, just leave off the .py extension. Okay. Well, so let me get back to testmod.py. And let me change the name of this thing to conform to what I've got in the notes here. So I'm going to say File, Save As, My Module. Now, the editor will automatically attach the .py extension. I don't need to do that myself. And let me copy in the code that I have here on slide 28. Okay, so the name of this file is mymodule.py in the comment, and I will copy and paste that stuff there. Now, the indentation is not preserved, and this function is actually not defined to do anything. So let me just change this function to print hi so that it's got something to do. Now, the purpose of this code down here at the bottom with this if statement, let me save this file, save, is to look at the dunder name variable's value when I run this module. If dunder name is main, then what I'm going to do is to test the fun1 call, the fun1 function, and I'm also going to use print to display the value of cnum, which is our course number. All right, so let me run this. I'm going to save it. I guess I already did that, and I'll run it. Okay, and fun1 has been defined, and cnum has been defined, and then because of the code in this if dunder name equals dunder main, because that test is true, fun1 has been called, and we are also going to display cnum. Now, if in some other module I do an import of my module, and when I run that other module, then an entire copy of my module is going to be pulled in. And when it's pulled in, it's also executed. So fun1 is defined, cnum is defined, but then because that module has been imported, when we test whether dunder name is equal to dunder main, that will be false because this is an imported module. It's no longer the main module, and consequently the test code is not executed. Let me reopen the testmod file that I had created before, testmod.py, and oops, I need to position that so that you can see the window. Let me drag that over. Here we go. All right. Actually, I'll move it down just a little bit. Okay, so we have my module in one editing window, and we have testmod in this other editing window. In testmod, I had said import math as m. Let me change this now to import my module as let's say. Print this is this is the dunder name module. Okay, so in test module, we're going to import my module as and then we're going to execute this print call, which is going to display this is the, and then the value of dunder name is going to be displayed, module. When I save and run this, Okay, now an entire copy of my module was pulled in by the import statement. And in that import statement, we defined the fun1 function. We defined the cnum variable to refer to 95888. But because that module was imported now rather than being the main module, this test failed, and we did not execute fun1, and we did not execute the print of cnum. So we did not see that information in the output. What we did see was the message, this is the, and then the value of dunder name, which was dunder main module. Okay, this is the main module. All right, so there's my module, and here is test mod, which is importing my module. All right, here's a little more detailed example, an alternative example, if you will. We're using this file called mymath as a test module to import, and in mymath, which is 2 slides long here, we're defining 3 functions. We're defining a square root function that computes and returns the square root of its argument. We're defining the cube function, which computes and returns the cube of its argument. And then we're defining mysum that computes the sum of all of its arguments and returns that value. So mysum we've seen before. We just got rid of the print statement that was in our original definition. Now the bottom half of this mymath.py function file, is we're going to test whether the name is main. That is, we're going to test whether I am currently executing this particular file. If so, I want to perform tests of my 3 functions. I want to test the square root function, I want to test the cube function, and I want to test the mysum function. On the other hand, if it's not the case that dunder name is equal to main, this test will fail. That is, this mymath has apparently been imported by some other module. And so what will happen instead is the else part down here is going to display this message. Imported module name is, and then dunder name. Since the name of this module is mymath.py, the value of dunder name here, if this mymath module is imported by some other module, is going to be mymath. Okay. So if I run the mymath function, pardon me, if I run the I'll get this right. Okay. So if I am editing the mymath.py file directly, and I execute the mymath.py module directly, that means it is the main module. It is the module that I have executed. And dunder name will be equal to dunder main, and the output will therefore look like this. Module name is main, square root of 3 is whatever it is, 12 cubed is 1728, and the sum of these values is 30. Let's do that to confirm that it does what I claim. I am going to open the mymath module here and drag it over so that you can see it. All right, so here is the mymath module. I have my 3 function definitions at the top and my testing code down at the bottom. If I run this, I should see the same result that I have here on slide 32. And there we go. So mymath is my main module currently. It is the module that I am directly running. Therefore, the dunder name variable is equal to dunder main, and I display the module name is main, and then I call the square root function, the cube function, and the MySum function to test them. These are the functions that I've defined up above. And I get the correct results. Now, I don't happen to have the square root of 3 memorized, but 1.73 looks pretty good. All right, so there we go. Now, here we have a separate program called myprog.py, which is importing mymath as mm, then creating a variable named x to refer to this integer value 123. If dunder name is equal to main, that is, if I'm directly executing this module file, this program file instead, then these print statements in here will be executed. And I display module name is dunder name, x cubed is, and then I call the cube function from the module, that is from the mymath module that I imported as and I'm also computing the square root of x, of 123. Now, I want to point out that when I do the import of mymath as the import is going to pull in all of this stuff and execute it. Now, up here, executing these function definitions simply means that the function definitions are performed. That is, these functions are defined. Down here, when we execute this test, dunder name is equal to dunder main, that will be false because mymath is not the current main module. mymath has been imported. Since this test fails, we're going to drop down here and display imported module name is, and this should be mymath. So this print statement is going to end up being invoked when in myprog.py this import statement is done. I meant to highlight the whole thing, not just the one word. Okay, so we will get one line of output when we do this import. Then we'll get 3 more lines of output as the remainder of myprog is executed. Let me open the myprog program file, and we'll test it. Okay, again, I gotta drag it over. Okay, so there's myprog. It's importing mymath as defining a variable x, and let's run this. Okay, there we go. So this line of output, imported module name is mymath, that was actually executed because of the else part of the code within the mymath.py module. Then the remaining 3 lines of output here correspond to these 3 print statements. Okay, module name is main, 123 cubed, and then square root of 123. Okay, so you can get into much more sophisticated structuring of modules in hierarchies called packages and so on. And there's also various ways of using so-called environment variables or configuration files or configuring whatever integrated development environment that you're using to indicate where these modules live and so on. But for our purposes, it's going to be good enough to simply have all of the module files that compose our overall program be in a single directory so that we can simply say import XYZ, and the assumption is that that means that we have an xyz.py file in the same directory containing the program that we're currently executing. Okay, so that gets us to the conclusion of talking about modules. And in the second half of the materials here, we'll look at the NumPy multidimensional array module. All right, so I'm going to post what I have accomplished so far. It's taking me longer than I anticipated. So I'm going to post part 1b of 2 parts, and then I'll post part 2 a little bit later as soon as I can get this NumPy part recorded. Okay, so take care, and I'll get this remaining part done as quickly as I can.